Alright. I did a RFID project with our Nexus board. Now Ben.
For if you don't look at my pants, smart.
So what we've done with the RFID is we've made a access system prototype. And this has two separate layers of security. The first layer is you have to have a valid RFID tag that you wave over the reader. Then you also have to have a pin that you type in on the keyboard. So we implemented RFID with a Texas Instruments reader that's on its own eval board. And we also have a pin which uses a PS2 keyboard connected to the Nexus board. And we send and receive data to the RFID reader via SPI. And then we receive input from the PS2 keyboard with UART. And then once those two pieces of information are input to the system, we match the RFID UID with a pin typed in. And then we'll grant or deny access to the user accordingly. And then it will be outputted onto the LCD screen.
Here's our hardware architecture, similar to everyone else's in all the other labs. We've got the keyboard going to the UART, RFID coming in through SPI, and the GPIOs to the LCD. Our hardware components, we have the micro-based software processor, our program data memory, GPIOs, and all that, the OPD for the SPI. And we have the actual board with the RFID chip on it. And of course the Nexus 2 board and our PS2 keyboard. Our software components, we have the initialize the RFID and SPI and all that good stuff. And then we have to read the UID from the RFID through the LiPo. And then on the LCD display, we have to display what it reads and then the login prompt and welcome or deny accordingly.
And basically, these are the steps that we went through in order to integrate our project. The first step, we pretty much just tried to test the hardware of the RFID, so we just plugged it into the computer via USB, and through the associated GUI that was included with it, we tested if the RFID could physically just scan a tag. And that worked, and that was good. And then next, we set up the hardware and assigned the package pins via the EDK and set up the microblaze. And then test 3, Dan will actually talk about.
Test 3 actually didn't go as we planned. It took us a long time to figure out what was going on, but we were having a problem with the microcontroller that's actually embedded onto the eval board, trying to compete with our microcontroller. And we were unable to disable the other microcontroller without disabling the RFID at the same time. And we tried various methods, and I can explain with the schematic what we actually did with that. But in the end, we weren't able to, and I wasn't about to cut the traces on the board because it's a $200 eval board. So.
And so our final tests and integrations were pretty much to set up the keyboard in order to put in your login pins, and then it would display the prompt and your RFID UID, and then you input your password, and then it would either say welcome and then your name if it passed, otherwise it would say that you failed. And there's also, you get 3 chances to log in your password until the system fails.
So here's a schematic. It's going to be hard to see, but there's a pin header here, and this is where we plug in the MISO and motion pins. And we also have slave select, and that's just for this header. And then there's another header up here where we get the S clock into the RFID. And then there's 3 pins right here in the bottom, and these will, if they're all the same when the RFID starts up, then it will go into parallel mode. But if these are different in any way, it'll evaluate them. And here we're going to have VDD and VDD and then ground, and then I will set this by. Some of the challenges we had is there's an enable line that's directly connected to the microcontroller, and when we pulled down the power on the microcontroller, we also pulled down the enable line, and we soldered a wire directly to this resistor right here, surface mount resistor, and tried to pull it up, but we didn't have enough voltage to pull it up, or enough current to pull it up, because it was sinking too much current into the microcontroller. So, in the end, it didn't work, the RFID side.
Well, for $200
Yeah, this eval board
Took an exact number.
obviously is not made to do this. Obviously, Texas Instruments wants us to use their products on their RFID, so we made a good board here that we can't really get around the microcontroller.